Hi folks, so welcome to another physics power up lesson, and today we're going to look at impulse. So the knowledge we're going to be covering in this power up lesson today will be, first of all, use the below relationship to solve problems for impulse, where F is the average force applied, delta T is the contact time, M is the mass, and V is the initial velocity, and U is the final velocity. The second one is know the definition of the impulse as either the area under a force time graph and the change in momentum of an object involved in the interaction. Now, we're really just going to focus on the second one here. I will do this first one in another power up lesson at some later point. Okay, so let's zoom in a little bit to see what it is that I would like you to know and what do we mean by these definitions. So first of all, the definition one we're going to focus on is change in momentum of an object involved in the interaction. So this is where the equation comes in. So we've got F delta T is equal to mv minus mu. So here, this is the change in momentum of the object, because remember, a change in physics is always calculated by the final minus initial. And so we have the units of kilograms meters per second, because that's literally what we do. We multiply the mass by the velocity, and this is the change in momentum. The second part is also the change in momentum, but here it's given by the average force applied over a short time interval. And I'll explain what this means a bit later on. And here the units are Newton seconds, because literally we're multiplying the force by the time. Force is always in newtons, time is in seconds, so that's why it's Newton seconds. Now, let's try and explain a little bit more about what this equation means and the impact it has for our problem solving. So first of all, you can use either units for impulse, ns or kilograms meters per second. And the reason for this is because if we look at the equation, there's an equal sign between these two parts of the equation, isn't it? And remember, an equal sign literally means that it means they are equal to each other. So that means it doesn't matter if we use this or this, they both mean the same thing. The second point I mentioned earlier is that it's an average force. Now, first of all, impulse is when we are applying a force over a very short time. Now, because we're applying over a very short time, we assume the force will be rapidly changing over that short time interval. So as a result, we can't say the force is 10 newtons, because that force might start off at 0, peak at 10, and then go back to 0 again. So this is why we use the average force. Now, I'm going to explain this again when we do impulse and the graph for impulse. So wait for that video and come back to that if you don't quite get it today. Final bit is that impulse can be calculated by either F delta T or mv minus mu. So remember this equation here, that equal signs tells us that this thing here is equal to this thing. Now, by the same argument, we can use this to calculate the change in momentum. We can also use this to calculate the change in momentum as well. And this is going to be a very key part of how we solve impulse questions, as you're going to see later on. Okay, so let's start with an example. And again, if you feel confident, you can try this yourself. If you're not, I will take you through the answers. So a cue hits a snooker ball of mass 4 grams at rest with a contact time of 0.2 seconds. The ball moves off with a velocity of 1.5 meters per second. Calculate the change in momentum. Calculate the average force applied to the cue. So pause it, have a go of it, and then I'll tell you the answer over the next couple of slides. Okay, so let's look at how we get the solutions here. So it's a calculation, so use your KFC technique, and hopefully you would have got this. Now remember that grams into kilograms, you divide by 1,000. Now, the one other thing you need to be aware of is that it does say the ball is at rest, so that means we also know the final velocity, which is 0 meters per second. How do we change momentum? Well, hopefully again, you would recognize once you've got your KFC down that the equation is mv minus mu. You plug in your values and you get this as your answer. And remember your units, kilograms meters per second. Now, moving on, remember to update your list of known answers there. So how do we get our average force? Well, hopefully by now you see we've got everything we need to use this equation here. And the delta t really gives it away that this is the equation you're using, because I can't really think off the top of my head what other equation has delta t in it. Once you've done that, it's just a case of plugging your numbers and rearranging it to give you the average force is 0.03 newtons. And that's how you do a very basic impulse question. Now, as always, check for understanding, have a go at this yourself, see how you do, and then I'm going to take you through the answers over the next couple of slides. So pause the video and have a go with it. Okay, so first of all, hopefully you did your KFC. And remember, we're working at the change in momentum. So it's mv minus mu, plug in your numbers, and we get this as our answer. Remember your units. And then to get the average force, we're using F delta T. Remember that delta T gives it away. And we're using our answer from before. And so we get this. Okay, now moving on. Obviously, we can make these examples a bit more complicated. Let's look at the next one. A boxer applies an average force of 200 newtons with a contact time of 8 milliseconds. His glove in his hands have a total mass of 600 grams. Calculate the impulse, state the change in momentum. Assuming the boxer's hand was stationary when launching the punch, calculate the final speed of his punch on contact. Again, if you're confident, have a go of it yourself. If not, I'm going to show you how to do it over the next couple of slides. Okay, now let's look at the answer for this one. So again, it's a good old KFC technique. So hopefully you wrote this down first. Okay, notice our mass was 600 grams. So that's 0.6 kilograms. Now notice the time was milliseconds. So to change that to seconds, you divide by 1,000. And we know that the force is 200 newtons. So to calculate the impulse, remember impulse in this case then is just Ft. So we just do F times T. And again, I would hope that doing your KFC, you can see that kind of gives it away. Plug in your numbers and we get the answer is 1.6 Newton seconds. So that's the answer to the first bit. Now, how do we get the second bit? State the change in momentum. Well, remember that our equation for impulse is F delta T is equal to mv minus mu. So what that means in words is that the impulse is equal to the change in momentum. So that means it's still 1.6 Newton seconds. And notice, remember I said to you, we can use Newton seconds or kilograms meters per second to mean the impulse. Similarly, if this is the change in momentum, then the impulse is also the change in momentum. So we can still use the units Newton seconds for the change in momentum. Okay, so to calculate the final velocity, we use the following, folks. Again, this equation here, we know we have the impulse, we know that the mass is 0.6 and we want the final velocity, and they tell you the initial velocity is 0, plug in the numbers, rearrange it, and we get the speed as 2.7 meters per second. As always, I'd like you to try and check for understanding by doing an example yourself. So have a go at this, pause the video, and then I'm going to go through the answer with you over the next couple of slides. Okay, so hopefully you were using your KFC technique and you wrote down what you had, and remember to convert to the correct units. So divide by 1,000 to give you kilograms, divide by 1,000 to give you seconds. And then the first one, to calculate the impulse, we do F delta T, so it's 500 times 0.006, which is 3 Newton seconds. Part 2, to state the change in momentum, same as before. Impulse is the same as the change in momentum, so it's 3 newtons per second. And then finally, calculating the velocity, we plug it into our equation, rearrange it, and we should get an answer of 7.5 meters per second. So see if you can try and spot the routine and the trick that the impulse is the same as the change in momentum. So to summarize, impulse is equal to the change in momentum. You can use either units for impulse, Newton seconds or kilograms meters per second. We use the average force to talk about the force here because the force is changing rapidly over a short time interval. Impulse can be calculated either by F delta T or mv minus mu, and by the same argument, the change in momentum can be calculated by mv minus mu or F delta T.